Welcome to the deep dive. Today, we're getting into something really central to a complex condition, how the prefrontal cortex shapes the way the brain handles reward in anorexia nervosa.
Yeah, it's a fascinating area. We've got quite a range of research to draw on here. Brain scans like fMRI, studies using magnetic stimulation, TMS, others looking at brain connections.
And reviews trying to pull the bigger picture together. So our mission for you, the learner, is to really distill the most important insights here. How does this, high-level thinking part of the brain, the prefrontal cortex, deal with reward when it comes to anorexia?
We want to get you that clarity, those key takeaways, without getting lost in absolutely everything.
Exactly. Okay, let's start maybe with the basics. How does reward usually work in the brain, just briefly?
Right, so typically you have this core circuit. Key players are the ventral tegmental area, the VTA, and the nucleus accumbens, or NJAX. They talk to each other using dopamine.
Dopamine, right. That's the neurotransmitter often linked to pleasure and motivation.
Precisely. Some key researchers way back highlighted dopamine's role, not just in liking rewards, but really in the wanting the motivation to get them. It drives anticipation.
Okay, so that's the standard picture. Now let's bring in a study from 2011. They used fMRI, trying to pinpoint brain activity right when someone gets information about a potential reward.
And this is where it gets really interesting for our discussion today. Their computer models suggested something quite specific about the flow of information.
Oh, what is that?
It seemed that information about the expected reward didn't just flow into the whole network, VTA and EGG, and this other key area, the dorsolateral prefrontal cortex, the DLPFC. Instead, the information seemed to enter this specific model network only through the DLPFC.
Wow, okay. So the prefrontal cortex isn't just processing it later down the line, it's potentially the gateway for that reward expectation signal.
That's what this particular study suggested for the network they modeled. And further, it indicated the DLPFC then influences the VTA and NAC when you're motivated by a reward.
Meaning it helps generate that feeling of, oh, I want that, or something good is coming.
Exactly. It points to the DLPFC having a role in creating that state of expectancy, that motivational drive, which definitely makes you think about what might be happening differently in anorexia.
Yeah, if that entry point or that modulation is altered. And didn't they also find something about the connections?
They did. They saw stronger connectivity, stronger communication from the DLPFC to the NAC, specifically during reward motivation.
But not necessarily between the VTA and NAC in the same way.
Right. The VTA-NAC connection was there sort of intrinsically,
Yeah.
but it wasn't boosted by the reward motivation in their analysis like the DLPFC-NAC connection was. It really emphasizes how influential the DLPFC seems to be in orchestrating this network when we're motivated.
Like the conductor, as you said. Okay, so that highlights the DLPFC's role in motivation. Now let's look at another study, this one from 2009, using a different technique, TMS.
Right? Repetitive transcranial magnetic stimulation. This is interesting because it allows researchers to sort of temporarily interfere with activity in a very specific brain area. In this case, the right DLPFC in healthy people.
They targeted a specific spot, didn't they, using coordinates?
Yeah, very precise, like brain GPS. They use coordinates x equals 44, y equals 44, z equals 18 to target that right DLPFC. And the task involved food. Participants rated how much they liked different food items.
Okay.
And then they had to bid on those items, essentially saying how much they wanted them. They did this before and after the TMS targeted the DLPFC.
And what was the effect of stimulating, or rather disrupting, the DLPFC?
Well, the TMS actually changed the relationship between their liking ratings and their bids. It shifted their bidding curve.
Meaning?
It suggests that DLPFC isn't just passively observing. It's causally involved in calculating the value we assign to food and how much we're willing to, work or bid for it.
So it directly impacts that economic decision about the food's worth to us.
Seems so. And this fits with the broader understanding of the DLPFC, right? We know it's involved in things like top-down control, overriding impulses, working memory, planning.
So this study, even in healthy people, really nails down that the DLPFC actively shapes how we value food rewards. Makes you wonder how that valuation process might be altered in anorexia.
Exactly. Is that computation itself different? And is the DLPFC driving that difference? These are key questions.
Okay, let's bring in another perspective. A 2009 paper looked at things like childhood temperament and personality traits like high harm avoidance, perfectionism, maybe negative emotions.
All right, traits that seem to crop up more often in individuals who later develop anorexia. The authors propose some ways these traits might link to prefrontal function, specifically the DLPFC.
How so?
Well, one idea is that maybe in anorexia, the DLPFC develops this excessive inhibitory control, like it's putting the brakes on too hard, dampening down the signals flowing through those typical reward pathways, especially for food.
Almost like deliberately suppressing the rewarding aspects of food.
That's one possibility. Or perhaps another way to look at it is that maybe the DLPFC becomes more active, but as a way to compensate for potential issues deeper in the brain, in the limbic system, the emotional centers.
So if the emotional reward signals are weak or confusing, the brain leans more heavily on the DLPFC's cognitive rules and control.
That's the hypothesis, relying on rules like I must restrict, rather than internal signals of hunger or pleasure.
But wait, if it's compensating by being more active, how does that fit with the idea of excessive inhibition? Are those contradictory?
That's a great point. It highlights the complexity. Maybe it's inhibiting certain pathways, like those related to food reward, while being highly active in maintaining rule-based behaviors or focusing on long-term goals.
Which fits with another point they made, this shift in values in anorexia away from immediate things like hunger satisfaction towards very long-term goals, like thinness.
Precisely. The DLPFC is crucial for planning, for future-oriented thinking. So altered function there could absolutely contribute to prioritizing those abstract long-term goals over immediate biological signals.
Okay, so the DLPFC is looking like a key player, potentially exerting too much control or involved in reprioritizing goals, but a 2015 paper offered maybe a slightly different emphasis.
Yeah, this model challenged the purely top-down view a bit. While acknowledging that cognitive control from areas like the prefrontal cortex is involved, maybe helping to ignore hunger cues, for instance, they proposed that fundamental changes in the brain's core reward system, the striatal dopamine system, are actually central to anorexia.
So maybe the problem isn't just the prefrontal cortex overriding things, but the reward system itself is functioning differently.
That's the idea. And they introduced this really interesting concept they called reward contamination.
Reward contamination, what's that?
It's the idea that somehow the neural pathways for reward and punishment might get inappropriately linked or overlapped. So behaviors that should be aversive, like severe food restriction, could paradoxically start to be processed as rewarding.
Wow. That's,
Right.
yeah, that really turns things on their head. Restriction itself becoming rewarding.
It's a difficult concept, but it might help explain the persistence of the behavior despite the negative consequences. And they suggest that altered dopamine function, which we know involves pathways connecting to the prefrontal cortex, might play a role in setting up these aberrant reward associations.
So the prefrontal cortex might still be involved, perhaps interpreting or reinforcing these contaminated signals.
Potentially, yes. Receiving unusual signals and perhaps contributing to maintaining that cycle.
Okay, this really highlights the interplay between different systems. Let's talk connections now. A 2016 study looked at brain connectivity, the actual wiring, and how regions influence each other.
Right, using techniques to map out both structural connectivity, the physical pathways, and effective connectivity, which is more about the flow of influence between areas during a task. They looked at people with anorexia and bulimia.
And what did they find regarding the prefrontal cortex?
They found pretty widespread differences in these taste, reward, and appetite-regulating pathways compared to healthy controls. Specifically, they saw greater structural connectivity, stronger physical links between the insula.
The insula involved in taste and body sensations.
Exactly. Stronger links between the insula and parts of the orbitofrontal and prefrontal cortex in both eating disorder groups.
So potentially more communication or interaction between these areas involved in taste, body state, and cognitive control.
It could suggest that, yes. But interestingly, they also found lower connectivity in some pathways, like from the orbitofrontal cortex down to the hypothalamus, which is critical for regulating basic drives like hunger.
Okay. So more connections in some places, fewer in others. And what about when they actually tasted something sweet?
During sweet taste stimulation, they saw differences in effective connectivity too. For example, the anterior cingulate cortex, another prefrontal region involved in monitoring conflict and emotion, showed connectivity to the ventral striatum, a key reward area.
So it's a complex pattern of altered connections, isn't it? It seems these changes in taste and reward processing in eating disorders really involve a network, including the prefrontal cortex, the insula, the striatum, and even the hypothalamus.
Absolutely. It's not just one region. It's how the whole network is wired and communicates that seems to be different.
Okay, let's consider a 2018 review that framed eating disorders as potentially reward-dependent syndromes.
Yes. This paper pulled together a lot of findings, suggesting that, as we've touched on, restriction might become rewarding in anorexia, while maybe binging in bulimia serves to reduce negative feelings.
And they highlighted studies using rewards totally unrelated to food, right? Like money.
Exactly. fMRI studies showing altered activity in the striatum and prefrontal cortex in response to winning or losing money in people with anorexia. And crucially, these differences were sometimes seen even after weight restoration.
That's such an important point. It's not just about being underweight. These brain patterns can persist. What did they find specifically about the prefrontal cortex response in these tasks?
Well, in individuals recovered from anorexia, they observed an exaggerated response in dorsal executive regions, which includes the DLPFC, to both winning and losing money.
Both, not just losses.
Both wins and losses, which might suggest, again, this heightened inhibitory activity or maybe difficulty discriminating between positive and negative feedback signals at that level.
So even with money, this tendency towards perhaps increased behavioral inhibition, potentially linked to an overactive prefrontal cognitive circuitry, seems to show up.
That's a leading hypothesis, yeah. It strengthens the idea of a potential core difference in how the prefrontal cortex processes feedback, positive or negative.
Now let's look at another study, this one from 2016, that looked at unconscious reactions to cues related to the illness itself.
Right. This used a startle reflex method.
Yeah.
They looked at women who had recovered from anorexia and measured their implicit, sort of gut-level motivation towards what they called illness-compatible cues.
Which were things like?
Images of underweight bodies and exercise, things often associated with the goals or behaviors in anorexia.
And what was the reaction in the recovered group compared to controls?
In their normal baseline state, the women recovered from anorexia actually showed an implicit appetitive motivation. They were drawn towards these cues, unconsciously more than healthy controls were.
So subconsciously, those thinness and exercise cues were still appealing or motivating.
That's what the startle reflex data suggested. But here's the really critical part. They did another condition where they temporarily lowered the participants' dopamine levels.
Okay. And what happened then?
That effect vanished. When dopamine was low, the recovered group no longer showed that heightened appetitive response to the illness cues.
Wow. So that unconscious positive associations seem to be dopamine dependent. Where does the prefrontal cortex fit in here?
While this specific study didn't directly image the DLPFC during the task, the researchers strongly implicate it as part of the wider brain network involved. Given everything we know about the DLPFC, dopamine, and reward valuation, it's highly plausible it's involved in assigning this dopamine-mediated reward value to these illness-related cues.
Makes sense. Okay, one last piece for context. A 2021 study looking more generally at reward, not specifically anorexia.
Yeah, this one focused on frontostriatal connections between the frontal lobes, including the DLPFC and the striatum in relation to wanting versus liking rewards.
The distinction between motivation and pleasure again.
Exactly. And they looked at how opioid and dopamine systems influence this. They found that blocking opioid receptors with naltrexone affected wanting and liking differently. And importantly, it specifically impacted the connectivity between the DLPFC and the striatum related to the wanting component.
So even outside of eating disorders, that DLPFC striatum link seems critical for the motivational drive, the wanting aspect of reward.
Precisely. It just provides more general biological backing for the idea that the prefrontal cortex is deeply involved in the motivation side of reward processing.
Okay. So let's try to pull all these threads together. After diving into all this research, what's the picture that emerges about the prefrontal cortex and reward in anorexia and nervosa? It's definitely not simple.
Not at all. It's clear the prefrontal cortex, especially the DLPFC, is playing a really critical, very complex role. It's not just about a blunted response to reward.
Right. It seems involved right from the start, potentially as an entry point for reward information in some models.
Yes, and it exerts significant top-down control over those core reward areas. In anorexia, this control might become, well, excessive or misdirected.
Inhibiting typical food reward responses, perhaps?
Potentially, yes. And maybe, paradoxically, involved in assigning reward value to restriction, or those illness-compatible cues we discussed. There seems to be this complex reevaluation happening.
And dopamine seems key in this altered valuation, particularly involving prefrontal pathways.
Absolutely. Altered dopamine signaling interacting with prefrontal function seems central to these changes in reward processing and motivation.
So for you, the learner, listening to this, the big takeaway is that the prefrontal cortex in anorexia isn't just sitting idly by or simply failing to register pleasure. It seems actively involved in a profound shift in what the brain considers rewarding.
Yeah, driven by these potential changes in connectivity, in top-down control, and in neurochemistry like dopamine. It moves us way beyond just thinking they don't enjoy food to seeing how these high-level cognitive systems are actively participating in the condition.
Which really underscores the complexity, and it leaves us with a provocative thought, doesn't it?
It does. If the prefrontal cortex is so central to both the cognitive control aspects and this altered reward processing in anorexia, could treatments that directly target prefrontal activity be beneficial?
Things like specific types of cognitive therapy designed to retrain those valuation processes, or maybe even neuromodulation techniques like TMS, which we saw used experimentally. Could they help recalibrate how the brain processes reward?
It's a really important avenue for future research and treatment development, exploring ways to potentially modulate that prefrontal activity to help restore more typical reward function.
Definitely something to think about. If this has sparked your interest, you can definitely dig deeper into the studies we touched on or the broader neurobiology of eating disorders. It's a rapidly evolving field. Thanks for joining us for this deep dive.